we are done with the discussion part regarding functions, and we are ready to answer some exercises. I will read problem number 1. For f of x is equal to 3x raised to 2 plus 4x plus 2, determine the following: f of negative 2, negative 1, 0, positive 1, and positive 2. All we have to do is substitute these values to variable x. Let's start with f of negative 2. Okay, so f of negative 2 will be equal to 3 multiplied by negative 2 raised to 2 plus 4 multiplied by negative 2 plus 2. Then, let's continue solving this one. If you remember, just follow the PEMDAS rule. I will just write it down. PEMDAS. Which means the sequence of priority will be parenthesis, exponent, multiplication, division, addition, and finally subtraction. Okay, so it's time to solve this problem for the first part. So, there are no other operations inside a parenthesis. Therefore, let's go to the exponent. So, there is an exponent here. Just copy this positive 3. And then, negative 2 raised to 2 is equal to positive 4. And then, we can already perform the operation for this term. So, 4 times negative 2 is equal to negative 8, and the final term plus 2. Okay? If you look at this, the remaining operations are addition and subtraction. And there is a rule that for addition and subtraction, all we have to do is just compute this from left to right. Therefore, 4 times 3 is equal to 12. Okay? Let's just compute this from left to right. So, 12 minus 8 is equal to 4 plus 2 is equal to 6. Therefore, for your f of negative 2, it is equal to 6. Positive 6. Let's move on to f of negative 1. So, for your f of negative 1, the same process, substitute negative 1 to variable x. That will be 3 negative 1 raised to 2 plus 4 multiplied by negative 1 plus 2. Following the PEMDAS rule, let's immediately solve this problem. So the exponent first, negative 1 raised to 2 is equal to positive 1, and then multiplied by 3 is equal to positive 3. Okay? Positive 4 or plus 4 multiplied by negative 1 is equal to negative 4. And the final term, just copy this one, plus 2. Once again, the remaining operations are just addition and then subtraction. We just have to compute this from left to right. 3 minus 4 is equal to negative 1 plus 2 is equal to positive 1 or just 1. For f of 0, it is equal to 3 multiplied by 0 raised to 2 plus 4 multiplied by 0 and finally plus 2. Okay, if you look at this, all numbers multiplied by 0 is equal to 0. So, let's just cancel these following terms. 3 multiplied by 0 raised to 2 and 4 multiplied by 0, leaving behind 2. So, the answer is 2. For f of positive 1, it will be equal to 3 multiplied by 1 raised to 2 plus 4 times 1 plus 2. Okay? So, this whole term will be equal to 3. 1 raised to 2 is equal to 1 multiplied by 3 is equal to 3. For this term, it is equal to 4 and finally plus 2. 3 plus 4 is equal to 7 plus 2 is equal to 9. That will be your answer for f of 1. And the final part, f of positive 2. Okay? So it will be equal to 3 multiplied by 2 raised to 2 plus 4 times 2 plus 2. Okay? Look at this. The priority is this exponent first. 2 raised to 2 is equal to 4 times 3 is equal to 12. 4 times 2 is 8, and finally plus 2. And then just add these following numbers. 12 plus 8 is equal to 20 plus 2. The answer is 22. That will be the solution for your problem number 1. This is our problem number 2. For g of h is equal to 4 minus 3h plus 8h raised to 2, determine the following: g of 0, 2, negative 4, and negative 3x. For the first 3 parts of this problem, I will just write down the answers because the solutions have the same process with sample problem number 1. For your g of 0 is equal to 4, g of 2 is equal to positive 30, and g of negative 4 is equal to 144. For the last part, which is g of negative 3x, don't be confused if there's a letter involved, which is x. The concept is still the same, and just treat this letter x for this part as a constant. Let's try to solve g of negative 3x. g of negative 3x is equal to 4 minus 3, and this h will become negative 3x, plus 8. H will be negative 3x, and don't forget the exponent 2. For this term, let's just copy. This is 4, and negative 3 times negative 3x is equal to positive 9x, plus 8. And since it has an exponent, let's prioritize this one first. So negative 3x raised to 2 is equal to 9x squared. We can still simplify this one. Once again, just copy these terms. 4 plus 9x plus, okay, 8 times 9x raised to 2 is equal to 72x squared. For this one, we cannot already perform simplification. Therefore, this will be our final answer for g of negative 3x. And one thing more, there is no assigned value for x. That is why we just have to leave this as it is. Let us read problem number 3. For s of t is equal to t multiplied by t plus 1 raised to 2, determine s of a, negative 1, and x plus 3. For s of a, it is equal to a multiplied by a plus 1 raised to 2. All of these variables t become a. Then, let us try to expand this one. A multiplied by a raised to 2 plus 2a plus 1. This can be your correct answer, or we can also use this distributive property, wherein we are going to multiply letter A to all of the terms inside this parenthesis. A multiplied by a raised to 2 is equal to a raised to 3 plus a times 2a is equal to 2a raised to 2, and finally a times 1 is equal to a. This can be your another final answer. For s of -1, just substitute this value or number -1 to the variable t. It will be -1 multiplied by -1 plus 1 raised to 2. Let us first perform the operation inside this parenthesis. -1 plus 1 is equal to 0. Then, let us raise this to 2, which is still equal to 0. And let's just multiply this by -1, and the answer is still 0. For the final part, we are going to determine s of x plus 3. So all of these variables t will be turning x plus 3. Okay, let's start solving this problem. X plus 3 multiplied by x plus 3 plus 1, and don't forget this exponent 2. Let us first perform the operations inside this parenthesis. I will just copy this one. X plus 3, and then this will become x plus 4, and don't forget the exponent. Then we can already expand this one. X plus 3 multiplied by x raised to 2 plus 8x plus 16. We can also perform distributive property for this example. We just have to multiply each of this term here by all of the terms inside this parenthesis. Let us start with x. So x times x squared is equal to x cubed plus x multiplied by 8x is equal to x raised to 2 plus x times 16 is equal to 16x. Next, let's proceed to 3. 3 times x squared is equal to 3x raised to 2 plus 3 times 8x is equal to 24x, and the final term 3 times 16 is equal to 48. We must have to simplify this one. We just have to combine those similar terms. Let us start with the term with the highest exponent for x. So this is x raised to 3, and this is the only term that is raised to 3. Plus, for x raised to 2, there are two terms ending with x squared. All we have to do is just combine them. 8 plus 3 is equal to 11x squared plus, for terms ending with just x, there are just two. Therefore, 16 plus 24, the answer is 40x, and then the remaining term 48. And this will be our final answer for s of x plus 3. For number 4, if f of x is equal to x minus x raised to 2 divided by 1 plus x raised to 2, find f of tangent x. From this exercise, it is an application of a rational function because there is a division of two polynomials and a trigonometric function. Okay, this is our original function here. We just have to find for tangent of x. And the same process, we just have to substitute tangent of x to the variable x, leading to tangent x minus tangent of x, that is raised to 2. Please don't forget the exponent. Next, for your denominator, it will turn into 1 plus tangent of x, that is raised to 2 as well. Then, let us try to simplify this one. In order to simplify this one, we must have to apply a concept from our trigonometry subject, which is called identities. I will just try to write this down. Identities. If you are not familiar with them, please take time to research them. Or if you are able to learn this concept, please try to recall this lesson. Now let's continue. According to your identities, tangent of x is equal to sine of x divided by cosine of x. We must have to substitute this one to tangent of x. Therefore, this will lead to this another step. Sine of x over cosine of x minus sine squared x over cosine squared x. Take note that this is raised to 2. And then for your main denominator, 1 plus sine squared x over cosine squared x. Then, the same process, we must have to simplify this one. In order to simplify this one, we just have to perform the operations for your numerator and then your main denominator. For our main numerator, we treat them as fractions. Technically, they are really fractions. For fractions involving addition and subtraction, we must have to find the LCD or the least common denominator. The LCD of these two is cosine squared x, and then, like fractions, we just have to divide this cosine squared x divided by cosine of x and multiplied by sine of x, leading to this expression, sine of x times cosine of x. And don't forget the subtraction sign. Minus, the same process, divide, and then multiply. Therefore, cosine squared x divided by itself multiplied by sine squared x, the answer is sine squared x. Now we are done with the main numerator. Let's go to the main denominator. For whole fractions, we already know that the main denominator is 1. The same process, find the LCD, and this is cosine squared x. And the same process applies, divide, and then multiply. Divide, and then multiply, and please don't forget the addition sign, leading to this 1 for our main denominator. Then, once again, let us try to simplify this one. If you notice, there are exactly the same similar terms for the denominators of each. That is why we just have to cancel them. And if we are going to notice, for this expression, it is another concept under identities. Accordingly, sine squared of x plus cosine squared x is equal to 1. This expression is also the same with this one. Their difference is just the placement, but overall, they are still the same. Therefore, cosine squared x plus sine squared x is equal to 1. Then we just have to copy the remaining terms, which is this one. Let us try to simplify this once again. If you notice, for these two terms, 1 and 2, there is this similar part, sine of x. That is why we just have to bring out sine of x and then open and close parentheses, cosine of x minus sine of x. This is our final answer for your number 4. Okay, please don't be overwhelmed with this type of solution. I just try to include this type of exercise to show you that the application of functions is really very wide, wherein it can even cover trigonometry. Okay, let's go to items 5 to 7. For items 5 to 7, we must have to express the following functions through a formula. Let us start with problem number 5. The surface area of the cube as a function of the length of its edge. To solve this problem, we must have to place some representations first. Number 1, surface area. Let's just try to have a symbol of capital SA. It refers to the area of the whole surface of this particular cube. Next, for the length of its edge, we just have to base this from this figure, which is small letter s. And we already know that all edges of this cube are equal. Next, let us try to write down the formula. So the surface area is a function of the length of its edge. To start, we already know that the area of this particular face of the cube, which is a square, is s raised to 2. Then, the number of faces this cube has is 6. Therefore, we must have to multiply this by 6. And the formula will be the surface area as a function of the length of its edge is equal to 6s raised to 2. This clearly shows that we can assign any value for variable s, wherein it will result to a corresponding value for SA, or the surface area. So this will be our final answer. For number 6, the temperature in Kelvin as a function of temperature in degree Celsius. Okay, let us try to represent Kelvin as capital letter K. Okay, must have to write this down. And then capital letter C for degree Celsius or degree centigrade. These two are the units for temperature. From our basic science or basic chemistry, we often use this constant 273, or for others 273.15. However, both of these constants are still correct. You may use any of these two. When we are converting Kelvin to degree centigrade, we use the operation subtraction. On the other hand, if we are going to convert degree Celsius to Kelvin, we must have to use this operation addition. And the number to be added is this constant. For this problem, let us try to use this one, 273.15. So from the statement of the problem, the temperature in Kelvin, which is the unknown, is a function of the temperature in degree Celsius. And it is equal to, okay, the variable capital letter C plus 273.15. We must have to use the operation addition since this Kelvin is the one that is unknown. And this is our formula for number 6, and this will be our final answer. For number 7, the volume of a cylinder in centimeters cube, please take note of this. as a function of its height, which is in centimeters, if the area of the base is 20 inch raised to 2. We are going to represent volume as capital letter V. This will be our volume. And the height of the cylinder, which is this one, we are going to represent this as small letter h. So this will be our height. The common equation for the volume of the cylinder is volume is equal to pi radius raised to 2 multiplied by height. This pi r raised to 2 refers to the area of the base, which is a circle. And the area of the base is already provided, which is 20 inch raised to 2. This can be written as the volume of the cylinder as a function of its height is equal to 20 inch raised to 2 multiplied by small letter h, which is the height. However, this is not our final answer because the problem requires the volume to be in centimeters raised to 3 or centimeters cube. Unfortunately, the area of the base is in inches raised to 2. We must have to convert this one. And the conversion factor is 1 inch is equal to 2.54 centimeters. Others use 2.5 centimeters. That can also be correct. But for this problem, let us try to use this conversion factor. Therefore, we must have to convert this 20 inch squared. So, 20 inch raised to 2 multiplied by a fraction, which is our conversion factor. 1 inch will be at the denominator, and then 2.54 centimeters will be at the numerator. Why? In order for this inch to be cancelled. And then don't forget this conversion factor to be raised to 2, so that centimeters raised to 2 will be coming out. So we are able to cancel this one, and the answer will be equal to 129.032 centimeters raised to 2. This will be our new constant. Let us try to write the correct formula. So the volume of the cylinder as a function of its height is equal to 129.032 centimeters raised to 2 multiplied by its height, which is in centimeters. And the result will be a volume in centimeters cube. And this will be our final answer. For number 8, we must have to draw the curve, which is y is equal to 0.5x raised to 3. This is already an example of a power function. Okay. And this is already our graph. We already have our own x-axis and then y-axis. Let us just try to place some values for x and then determine their corresponding values for y. From that, we already have our own points, and then we can plot the points on this graph wherein we can already discover the curve for this exercise. I already prepared a table here. This is a column for our values for x, and then this is the column for y. For this example, let us try to place an increment which is smaller, let us just say the difference is just 0.5. For values of x, let us start with -2, and then let's proceed to -1.5, -1, -0.5, 0, and then +0.5, +1, +1.5, +2, +2.5, and lastly, +3. Then using this equation or formula, we are going to find for the value of y. For this example, I am just going to write down the values for y. For your own sake, please try to solve the values for y on your own and then try to check with my own values. Okay, let us start. If x is -2, y is -4. If x is -1.5, y is -1.69. However, for this example, let us try to round this off to -1.7 so that it is easier to plot the points. If x is -1, y is -0.5. If x is -0.5, y is 0.06, or it is nearly 0.1. If x is 0, y is 0. And by the way, please don't forget this should be negative. Okay, let's proceed. If x is 0.5, y is 0.06 positive, or let us try to round this off to 0.1. If x is 1, y is 0.5. If x is +1.5, y is +1.69, or 1.7. If x is 2, y is +4. If x is 2.5, y is 7.81, or 7.8. And lastly, if x is 3, y is 13.5. Our points are now complete. We can now plot these points to this graph. Let us start with -2 and then -4. So if x is -2, which is this one, y is -4. So count 4 grids downward. 1, 2, 3, 4. So this is our first point. If x is -1.5, y is -1.7. Please don't forget the sign negative. If x is -1.5, y is -1.7, which is near -2. If x is -1, y is 0 or -0.5. If x is -0.5, y is -0.06. And then, finally, the half. If x is 0, y is 0. We are done with the first half. Let's proceed. If x is +0.5, y is +0.1. If x is 1, y is 0.5. If x is 1.5, y is 1.7. If x is 2, y is +4. If x is 2.5, y is +7.8. 4, 5, 6, 7.8. If x is 3, y is 13.5. Let us just try to count 13.5 grids upward. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.5. Then let's just try to connect these points. Okay. Please apologize for my inaccurate curve. So our curve will be like this. And take note, there are arrow signs at the end indicating that this line can still proceed if we are going to add more points. Okay, this is the curve for this exercise. However, I must have to emphasize that this is not just the curve for the power function. If you are going to try to determine the curve for y is equal to 0.5 x raised to 2, you are going to expect a different curve. That will be the end of our functions. You are already provided with exercises to learn more about this first topic for differential calculus. Okay, we are done with our first preliminary topic. We can now proceed to our next lesson, which is limits.